Hello student, this video lecture is prepared for heat transfer subject and I will discuss the unit number 4, that is condensation and boiling. In previous lecture, we have discussed how to calculate the rate of heat transfer and mass flow rate of condensation in a horizontal tube. And then I had discussed about the effect of non-condensable gases on condensation. Now today's lecture I will discuss the heat transfer to the boiling liquids, then what is meant by pool boiling. There are different types of pool boiling, and if the time permits I will discuss the pool boiling curve. So let us start the lecture. So heat transfer to the boiling liquids. So boiling is a convection process that involves a change in phase from liquid to vapor. So this is the definition of boiling. So whenever there is change of phase from liquid to vapor, that process is called a boiling, and it is also called a convection process because the fluids is involved. Which fluids? Gas or liquid or vapor. So these fluids are involved in this process, so it is called a convection process. And when the boiling is occur when the liquid is exposed to the solid surface maintained at a temperature higher than the saturation temperature of the liquid. That means if we are heating the liquid, suppose in this case, we have to maintain this surface temperature higher than the saturation temperature. So what is meant by saturation temperature of the liquid? Saturation temperature of the liquid is nothing but the boiling point of that liquid. So if we maintain the higher temperature, for example, if you are boiling the water, so you have to maintain higher temperature, suppose 110 degrees Celsius here. Then what is the saturation temperature of that water? 100 degrees Celsius. So the boiling process is taking place. And the boiling is generally depends upon the difference between the surface temperature and the saturation temperature of the liquid. So that means in case of boiling, delta T is given as delta T is equal to TW minus TS. So where TW is the temperature of the surface, maybe this surface or this surface, and TS is the saturation temperature of the liquid, that means boiling point of that liquid. And sometimes it is when this difference TW minus TS is taken for calculation, it is also called a excess temperature. So this is called a boiling. So all this process is called boiling. So what is the application of the boiling in chemical industry? For example, if we take distillation, evaporation and steam generation. So these are some typical examples of a boiling where the boiling process is carried out. So in case of distillation, you have to separate the liquid mixtures according to their boiling point or their vapor pressure. So this is called a reboiler. So less volatile component is heated here and more volatile component is taken out from this condenser. Okay, so actually boiling is taking place in this heat exchanger. So this heat exchanger is called a reboiler. So in this process also we use the boiling. Similarly, in case of evaporation, we have to separate the solute from the solvent. That is called a evaporation. So you have to feed that solute or solvent mixture here, and steam is admitted from here, and steam is condensed. So that steam gives the heat to this feed, and the solvent is evaporated, which is taken out from here, and the thick liquor, which is called a concentrated, that solute is called a thick liquor. So that is taken out from here. So this process is called a evaporation. So in this process also the boiling is taking place. The next one is the steam generation, or you can say the boiler. So in case of boiler, we have to feed the water from here. This water is heated by means of a flue gases. So fuel plus air mixture is admitted from here. So from this flue gases is prepared from this fuel and air mixture, and these flue gases are circulated through these tubes. So these flue gases gives the heat to this water, and this water is converted into the steam, and the steam is taken out from here. So this is the typical another example of a boiling which is used in a industry. So in chemical industry, the one of the type is called a pool boiling. So what is mean by that? When the heat is added to a liquid from a submerged solid surface, then the boiling process is known as pool boiling. So you have to maintain the pool. So this is called a pool of liquid. So you have to maintain certain level of that liquid. So it is called a pool boiling. And if the boiling is taking place in this equipment, that is called a pool boiling. So here this is the heating element, maybe coil, and the pool is maintained around this coil. So the boiling is taking place here. So it is called a pool boiling. And in this case also, the heating is carried out here, and the liquid pool is maintained here. So it is also called a pool boiling. So what is happening in a when the boiling is taking place? When you heat the any surface, suppose here, the bubbles are created. So these bubbles are having the low density, so it will rise through this liquid, and then it will goes to the surface of this liquid, and then it is evaporated. So in this process, the bubbles are created. That bubbles are goes in a upward direction, and this liquid is having higher density than that bubble. So this liquid is going downward side. So in this way, the circulation is naturally carried out in this equipment, and it is called a pool boiling. So note that, so pool boiling is nothing but you have to maintain the pool of liquid on that hot surface. So there are two types of a pool boiling. First is called a subcooled or local boiling, and second one is called a saturated pool boiling. So first we discuss what is meant by subcooled or local boiling. If the bulk liquid temperature is less than the saturation temperature, the process is called subcooled or local boiling. So saturation temperature is nothing but the boiling point of that liquid. Suppose if we are using water, so water is having 100 degrees Celsius boiling point. So that is called a saturation temperature of water. So if the saturation temperature is less, or that heating temperature is less than the saturation temperature, then that process is called a subcooled boiling or local boiling. So if we look at here, so the temperature of this liquid is 80 degrees Celsius, and 107 is the temperature of this hot surface, and the saturation temperature of water is 100 degrees Celsius. So here the heating is taking place below the saturation temperature of that water. So this type of a boiling is called a subcooled boiling or local boiling. Okay. So the pressure is maintained as a atmosphere pressure, 1 atmosphere. Okay. Then another type, that is known as a saturated pool boiling. So when the heat is added to the liquid from a submerged surface and the liquid is maintained at a saturation temperature, then the process is called saturated pool boiling. So here in the second case, the temperature of that hot surface is 107 degrees Celsius, and this temperature, this liquid temperature is maintained 100 degrees Celsius. So boiling which is taking place here is called a saturated pool boiling. Okay, so these are the two types of a boiling, pool boiling and subcooled or local boiling and saturated pool boiling. Then the process of the boiling depends upon the nature of surface. So what is the nature of surface? Then thermodynamic properties of the liquid, that means viscosity, density, temperature. So all these parameters we have to consider. Then the vapor bubble dynamics, so how the vapors are formed here. Then these vapors are goes on the surface of that liquid, and the circulation current is created in this liquid. So that is called a vapor dynamics. Generally the boiling process is complicated. So we will discuss what is the effect of that surface tension on the bubble formation. So surface tension is also important parameter in case of boiling. So if the surface tension of the liquid is very high, okay, then the bubble tends to spread along the surface, so like here, and blanket the surface rather than leaving from the surface to make a room for other bubble. So instead of moving this bubble in the upward direction, these bubbles spread on that heating surface. So this will happen when your surface tension of that liquid is very high. So this is shown in this figure C. And if the surface tension is low, so like this, it tends to wet the surface and the bubbles will pinch off. That means it will be taken off easily and rise as shown in figure 3.12a. So this is 3.12a figure. So if the surface tension is low, at that time the bubbles are formed like this and they will move in this direction, upward direction, pinch off. That means it will move from this direction and another bubble is created. And if the surface tension is having intermediate value, then the bubbles are formed as shown in figure B. So if the surface tension is intermediate, that means like this, so the bubbles are formed like this. Okay, so these are the effect of surface tension on the bubble formation. So if the liquid is having low surface tension, the boiling process is taken place easily. So this is the conclusion from this diagram. Then we will discuss the pool boiling curve. So for that we have to consider one experiment. In that experiment we have to heat the liquid by using a horizontal tube bundle. Bundle means there are number of tubes, 50, 60 like that. So this is called a tube bundle, which is submerged in a pool of liquid. That means some liquid level is maintained and steam is condensing inside the tube. So in that horizontal tube bundle, the steam is condensed. That means steam is circulated. And let Q by A. So what is meant by Q? Q is rate of heat transfer and A is the area of that equipment or that surface. That is called a heat flux. And delta T, as we already discussed, TW minus TS. So this is the temperature difference between the tube wall and the boiling liquid. And just we have to start with the small temperature drop. So just we have to maintain small temperature drop here, and then we have to go on increasing the delta T. Then we will obtain one curve. So that curve we will discuss in the next lecture. So thanks.